Welcome everyone. Today, we'll discuss how managing environmental factors can protect materials and prevent issues like corrosion, erosion, and mechanical damage. This is a critical topic for ensuring equipment reliability and reducing maintenance costs. Environmental control plays a vital role in industrial systems. Corrosion, erosion, and mechanical damage can lead to costly repairs and safety hazards. By understanding these issues, we can see why controlling environmental conditions is essential for long-term equipment performance. Corrosion, erosion, and mechanical damage are critical issues in industrial systems, particularly in vessels, pipelines, and storage tanks. Corrosion occurs when metals react with environmental elements such as oxygen and moisture, leading to material degradation and structural failure. Erosion involves the gradual removal of material due to fluid flow or abrasive particles, while mechanical damage can result from physical impacts or operational stresses. These phenomena not only compromise equipment integrity but also lead to costly repairs, downtime, and safety hazards. Understanding these mechanisms is essential for implementing preventive strategies. Environmental control is a proactive approach that modifies the surrounding conditions to minimize these risks. By controlling factors like humidity, oxygen presence, and chemical composition, industries can significantly extend equipment life, reduce maintenance costs, and ensure operational reliability. This introduction sets the stage for exploring why environmental control is a preferred method and how it effectively addresses these challenges. Environmental control is crucial because it targets the root causes of corrosion and related damage rather than merely treating symptoms. By altering environmental parameters such as humidity, oxygen levels, and pH, industries can create conditions that are unfavorable for corrosive reactions. This approach is cost-effective compared to frequent repairs or replacements and aligns with sustainability goals by reducing material waste. Furthermore, environmental control enhances safety by preventing leaks and failures that could lead to hazardous incidents. It also supports compliance with industry standards and regulations that mandate corrosion prevention measures. In sectors like oil and gas, chemical processing, and power generation, where equipment operates under harsh conditions, environmental control ensures long-term reliability and performance. The following sections will delve into specific methods, dehumidification, inert gas blanketing, and pH control, that exemplify how environmental control is implemented in practice. There are three main methods: dehumidification, inert gas blanketing, and pH control. Each addresses specific factors contributing to corrosion and damage. Dehumidification involves reducing the moisture content in the air surrounding equipment, particularly vessels in storage or standby. Moisture is a key contributor to corrosion because it facilitates electrochemical reactions between metal surfaces and oxygen. By lowering humidity levels, dehumidification interrupts this process, thereby preventing rust formation and material degradation. Common techniques include using desiccants, refrigeration-based dehumidifiers, and controlled ventilation systems. These systems maintain relative humidity below critical thresholds, often around 40%, to inhibit corrosion. Dehumidification is widely used in industries where equipment is stored for extended periods, such as marine vessels, aerospace components, and power plant turbines. The benefits include prolonged equipment life, reduced maintenance costs, and improved operational readiness. Implementing dehumidification requires careful monitoring of humidity levels and periodic maintenance of dehumidifying equipment to ensure consistent performance. Blanketing with inert gas, such as nitrogen, is a method used to eliminate oxygen and moisture inside vessels and storage tanks. Oxygen is a primary driver of corrosion, and its removal significantly reduces the risk of oxidation reactions. Nitrogen is commonly chosen because it is non-reactive, readily available, and cost-effective. The process involves introducing nitrogen into the vessel to displace oxygen and maintain a protective atmosphere. This technique is particularly effective for systems storing reactive chemicals, hydrocarbons, or materials sensitive to oxidation. In addition to preventing corrosion, inert gas blanketing minimizes the risk of fire and explosion by reducing oxygen concentration below flammable limits. Industries such as petrochemical, pharmaceutical, and food processing frequently employ this method to safeguard product quality and equipment integrity. Proper implementation requires monitoring pressure and gas purity to ensure consistent protection. pH control involves adjusting the chemical composition of fluids to reduce their corrosivity. Corrosion rates are highly dependent on pH levels, with acidic environments accelerating metal degradation. By maintaining a neutral or slightly alkaline pH, industries can significantly slow down corrosive reactions. This is achieved through the addition of buffering agents, corrosion inhibitors, or chemical dosing systems that regulate pH within desired ranges. pH control is essential in water treatment, chemical processing, and cooling systems where fluid chemistry directly impacts equipment longevity. Continuous monitoring and automated dosing systems ensure stability and prevent fluctuations that could lead to localized corrosion. The benefits of pH control include improved material performance, reduced scaling and fouling, and enhanced process efficiency. However, it requires careful selection of chemicals and adherence to environmental regulations to avoid secondary issues such as contamination or waste disposal challenges. Comparison of methods, best practices for implementation. Each environmental control method offers unique advantages and is suited to specific applications. Dehumidification is ideal for equipment in storage or standby, providing a simple and effective way to prevent moisture-induced corrosion. Inert gas blanketing excels in systems where oxygen elimination is critical, such as chemical storage tanks, offering dual benefits of corrosion prevention and fire safety. pH control is indispensable in processes involving fluid circulation, ensuring chemical stability and minimizing corrosive effects. While these methods can be used independently, combining them often yields superior protection. For example, vessels may employ both inert gas blanketing and pH control to address multiple risk factors. The choice of method depends on factors such as equipment type, operating environment, cost considerations, and regulatory requirements. A comparative analysis helps organizations select the most appropriate strategy for their needs. Implementing environmental control effectively requires adherence to best practices. First, conduct a thorough risk assessment to identify areas prone to corrosion, erosion, or mechanical damage. Select the appropriate method based on operational conditions, material compatibility, and cost-benefit analysis. For dehumidification, ensure proper sizing of equipment and maintain humidity sensors for accurate monitoring. In inert gas blanketing, verify gas purity and maintain pressure control systems to prevent leaks. For pH control, use automated dosing systems and regularly calibrate sensors to maintain chemical balance. Training personnel on system operation and safety protocols is essential to prevent mishandling. Additionally, integrate environmental control measures into preventive maintenance programs and document all procedures for compliance and auditing purposes. Continuous improvement through data analysis and feedback ensures long-term effectiveness and reliability. Summary and key takeaways. Environmental control is a strategic approach to preventing corrosion, erosion, and mechanical damage by modifying the surrounding conditions that contribute to these issues. Methods such as dehumidification, inert gas blanketing, and pH control address critical factors like moisture, oxygen, and chemical aggressiveness. Implementing these techniques not only extends equipment life but also enhances safety, reduces maintenance costs, and supports regulatory compliance. While each method has specific applications, combining them can provide comprehensive protection. Organizations should adopt best practices, including proper system design, monitoring, and personnel training, to maximize the benefits of environmental control. Ultimately, this proactive approach ensures operational reliability and sustainability in industries where equipment integrity is paramount.